In
this video, I will show you how you can create models of actuators, sensors and processes using the basic library of SIMIT simulation framework. I will also show you how you can make the simulation clearer using controls. The basic library covers a wide range of actuators for virtual commissioning, including components for simulating actuators with several speeds and both rotational directions and valve actuators. Using the Profi Drive components, you can simulate speed-controlled actuators which can be activated in accordance with the Profi Drive specification. With device-specific components, you can adapt the Profi Drive simulation to the Simorec converter or the Master Drive, Micromaster and Dynamics frequency converters. Components are also available that you can use to simulate the different Simocode Pro motor control devices. You can create actuator simulations simply by dragging and dropping the appropriate component from the task card onto the diagram and linking it with the control and feedback signals in the automation system. You can also drag and drop the signals from the Signals task card onto the diagram. By pressing and holding the Shift key, you turn the signal into a connector. You then link the connections of the component with the connections of the connectors, either by superimposing them on one another or by creating a connecting line. After you start the simulation, the actuator simulation reacts like the real actuator from the perspective of the automation system. The simulation creates the appropriate feedback in response to control commands. You can configure the simulation of pressure, temperature or similar physical values by entering the measuring range in the coupling editor or in a scaling component. The basic library contains components for simulating the Sivarex U weighing module and the FM350-1 counter module, which allow you to create other sensor simulations. RFID systems can also be found in the contact library. The standard library provides components with functions for developing simulation models. In addition to components for calculating basic mathematical functions and logic operations, you can also use components with general basic functions such as integration. This enables you to represent the simple and complex processes of your machine or plant realistically. For example, if a reactor is filled and emptied via valves, the reactor level reported to the control system is the result of the inflows and outflows. In simplified terms, to simulate the level, you can set up an integration across all the valve openings and pump speeds. To implement the simulation, you simply use components with the integration, subtraction and minimum functions. You connect the valve openings and pump speeds, which are the outputs of the valve and pump components, with the input of the subtraction component via the minimum component. Then you connect them with the integrator input. After this, you simply need to set the time constant and the threshold of the integrator accordingly. The simulation then supplies the level to the control system. This rises or falls in the same way as the real plant, depending on the control of the valves and pumps. Using version 8 of SIMIT simulation framework, you can also make changes while the simulation is running. For example, you can retrospectively incorporate controls for inputting and displaying values and components in your simulation. To do this, I go to the project view while the simulation is running and open the corresponding diagram in edit mode. To display the level and set the integration constant, I simply drag the analog display control element and a slider control element onto my diagram. After linking the connections with the appropriate inputs and outputs, I set the relevant parameters. Afterwards, I prepare the changes for the simulation by selecting the Prepare Changes function. Then I can load the changes into the current simulation. This is how you can easily incorporate displays and inputs into the simulation or make other changes to the model. This makes the simulation clearer and more flexible. The controls are ready configured in control windows for individual components. You can drag these controls from the control window onto a diagram, which makes it easy to add inputs and displays to your simulation. When the simulation is running, you can easily open the control window by double-clicking on the component, for example, in order to simulate manual operation of a standard actuator. SIMIT has a practical option for inputting and tracking values while the simulation is running, which involves forcing every input and output of a component. Simply open the Properties window of the component, force the corresponding connection and set the required input or output value. You can track the effects of forcing at the connections of linked components either in the Properties window or in the diagram. You simply need to activate the displays on the required connections. Finally, you can identify the current simulation load using the Simulation Load component. You will find it in the standard library under Miscellaneous. Simply drag and drop it onto a diagram. Once the simulation has started, you will see the current load distribution in the component's control window. In the example, the greatest load is generated in the coupling. If the load is too large, you can increase the cycle time accordingly or divide the model into several time slices. You can gain an initial impression of the load on your simulation using the tooltip symbol in the bottom right-hand corner. Using the basic library of SIMIT simulation framework to create models of actuators, sensors and processes. Fast, flexible and easy.